Before we get started, I want to tell you about my new book. It's called The New Mobility Handbook, Rethinking How We Get Around Cities. The book builds on my work on the Smarter Cars podcast here over the last 3 years as we've explored autonomous vehicles, ride-hail, and then micromobility, and the impact of all of these new technologies on cities. New mobility options are incredibly popular and can encourage multimodal travel in ways that public transit has not. But these options have also created new challenges for cities that can't be solved by technology alone. We need to combine these new mobility modes with urbanist policies to keep our roads moving. Transportation in cities will not be an either-or solution. We don't have to choose between ride services, bikes and scooters, or getting everyone to ride the bus. It's not either or, it's and. We're going to need all of these technologies working together to rethink how we get around cities. The New Mobility Handbook offers a grand unifying theory of sorts for how we can have the benefits and convenience of new mobility options while also meeting city goals to encourage multimodal travel and reduce traffic and pollution. If you're not familiar with the principles behind urbanist policies like congestion pricing, transit priority, reduction in parking, and reallocation of street space, the New Mobility Handbook provides an introduction to these policies and how they can be used together with new mobility technologies to improve transportation in cities. The New Mobility Handbook is available on Amazon in paperback and Kindle versions. I hope you enjoy the book. This is Smarter Cars, a podcast about autonomous vehicles and the future of transportation. Welcome to Season 5. This is your host, Michelle Kairouz. Today we're talking with Jason Stinson, the CTO and co-founder of Renovo. Renovo makes automotive software that helps companies manage data from autonomous driving and ADAS systems. Jason, welcome to the show.
Thank you. Well, thanks for having me here.
So let's start back at the beginning. I think it's in 2010. Can you give us the origin story of why you founded Renovo and what problem you guys were trying to solve?
Sure. Yeah, we actually just passed our 10-year mark just last month, so it's pretty exciting. My co-founder, Chris Heiser, and I started the company originally with the intention of bringing a lot of our background in Silicon Valley and technology into the automotive industry. We had a number of our friends that were early at Tesla and early at a lot of other companies that were doing connected car and electrification. And my co-founder and I had been friends for a long time, and we'd always been not only technologists, but we'd been deeply interested in cars. We both were passionate car people, and this seemed like a great opportunity to do something interesting in the space. We started the company originally with the idea that we wanted to basically help provide some technology in the automotive industry. We originally were thinking a lot about electrification. That was a big topic in 2010. We built effectively a platform around electrification, and one of the key concepts in that platform was the management of the data in the vehicle. We built an entire car. We built effectively an electric supercar. We debuted that in 2014 at Pebble Beach on the concept lawn. It was an exciting time. We worked with a lot of tier one suppliers. This is where we really learned a lot about automotive systems and automotive safety systems. We then started working on a project with Stanford, a project called Marty, and the cars team there, Professor Gerdes, which was their 5th generation autonomous vehicle. And that's where we started to realize that the platform, the software platform that we built for the Coupe really was well suited towards these new autonomous platforms that were coming up. And particularly what it was well suited towards was, again, that data management, application management, infrastructure layer. We weren't really as interested in the what we call the high-level brain functions, the perception engines, path routing, motion planning, prediction. We were more interested in the infrastructure layer. And that was a great program with us and a successful one with Stanford. And that's where we kind of really started to focus on providing that data management platform to other autonomous companies. And that's where we started working with Voyage. It's one of our companies that we work with on their autonomous fleet. And as part of this platform, again, the data management has been really important. What we've seen in the last few years is that aspect of the platform has really taken off. And it's not just applicable to autonomous vehicles, fully autonomous vehicles. It's also very applicable to advanced driver assistance systems, or ADAS, that they're generating massive amounts of data, and the OEMs and the tier ones are really struggling today to manage that data and to handle that data and to digest it and use it and store it and track it. And this platform that we've been effectively developing since 2010, the maturity of it, the safety of it, and our experience with it seems to resonate pretty heavily with our customers and with people working in both the ADAS and the AV space.
That's a really interesting evolution that kind of tracks the evolution in this part of the car space over the last 10 years, kind of starting with electric and then autonomous and then also ADAS. So the Coupe electric supercar, I have one question for you. Where is it now?
It's sitting in the shop floor of our facility. So we still take it out. We took it to a car show last year in Saratoga, which was a ton of fun. It was fun to show it. We still actually the same data systems that basically an earlier version of that data system that we use today is actually still in the Coupe. It still phones home on a regular on a daily basis, lets us know what our, this was, again, technology we were developing way back when, still puts data into our cloud, tells us what is the battery state, what is the temperature of various temperature sensors in the vehicle. If you drive it, it still pushes GPS data and battery data and throttle, steering, braking data all up into the cloud. So yeah, we still have it around. We still take it out for drives every once in a while.
That's great. When you think about a data platform, as you said, kind of even just the electric car having all this data and then seeing the even greater need with autonomous systems with Marty and then moving forward with Voyage and even companies with ADAS, I think a lot of us, when we look at the cars we have today, don't really understand or think about the data that's being generated. So can you maybe do a little comparison between, like, if you have a Toyota that you bought, just like a regular car, how much data is there and what happens to that data in the life of that car? And then maybe contrast it with Tesla and then with the needs that autonomous vehicles have. Like, how do the data profiles vary?
Yeah, it's a really good question. So, starting actually back in the 90s with GM's OnStar program, they started basically collecting bits of data from the vehicle, or having the ability to do that. At that time, it was kind of, if you think about a data pipeline, it was kind of a cocktail straw sized pipeline of data. It was relatively thin and light and not a lot of information, but it was enough for them to help their customers to identify problems with the vehicle or assist them in emergency situations. That industry and that data management is kind of moved pretty slowly, even to today. If you look at almost all the major OEMs today have some form of a telemetry system for their rank and file vehicles. It still is a pretty thin and sparse amount of data. You've seen that actually even, a couple of years ago, we had the rise of the OBD dongles that you would stick into the cars to augment that data that was being uploaded. You can see a lot of the insurance companies use that sort of information to offer discounts or to collect information, statistical information. So cars like that generate actually a ton of data, even if they're not ADAS vehicles or AV vehicles. They're generating a ton of data, and it's actually quite valuable data for a lot of reasons. It's valuable for feature development, looking at how things are going to develop going forward. It's valuable for validation, understanding when things fail, to go back in and during the development phase to understand how to fix those things, what happened. It's super valuable. Actually, we saw this with Uber a couple of years ago when they unfortunately had that fatal accident in Arizona. It's valuable from a liability standpoint. It's really valuable to be able to deconvolute what happened in the event of a problem. And then lastly, the part that I think a lot of people have been talking about the last few years is the revenue possibilities, the possibility to basically offer services off that data. So even existing cars today without any of these advanced features have a lot of information that can be used across all four of those categories. It still is relatively small data.
And where does it sit? Where, like, if you just have a Toyota and it's very basic and doesn't have any ADAS and it's still generating this telemetry type data, where does that data live and can anybody see it?
No. So in a traditional car today, modern car today, that data is ephemeral. It basically runs across the CAN bus or the flex bus, and it's used in very temporally and then disappears, goes away forever. The data that's pushed up to the cloud will typically live either in the small amount of data that the OEMs want to track, that will reside either in a telemetry unit, or oftentimes it'll be in the head unit. The center console has gotten pretty sophisticated in the last few years, so sometimes it'll be stored there. It's really interesting. The head unit is actually one of the areas where we've seen a lot of more data being stored, less so from an OEM perspective, but a lot from the infotainment side. Things like, your phone contact list and your last place that you were at and what your listening preferences are. There's a lot of data being stored inside of those head units, primarily to be replayed the next time the driver gets in the car, but that data is not leaving the vehicle. So that's kind of where a lot of the information sits. It's still if you look at the grand world of big data, it's still all pretty tiny amounts of data. We're talking, tens or hundreds of kilobytes of data, but it's still quite a lot of metrics data.
And so then jump us up to, say, a car with a more sophisticated ADAS system. What's going on with that data? Where does it sit? How often is it communicated over the cellular, over internet? How does that data get viewed or transferred?
Sure. So for the most part, that data definitely has to be stored somewhere. It can't be just super ephemeral where it occurs once and then disappears. But it ends up getting stored inside the components, the ADAS components within the vehicle. So you may have an object, something like a Mobileye IQ system, that will basically preserve the data for a period of time in order for it to do its predictive algorithms, to figure out what are its object classification algorithms. That, again, will live in individual components in the vehicle, but it, for the most part, doesn't leave the vehicle. And the reason for that is, in many cases, the OEMs simply don't have the data pipelines to get it off the vehicle. And so, but those ADAS cars are collecting, because the thing that generates lots and lots of data are the perception sensors. So a traditional car has wheel angles and throttle position, brake positions, brake pressure, temperatures, all these single numeric values. That's pretty small. Those are bytes of data. But all the perception sensors, maybe not ultrasonic sensors, but things like radar and increasing to LiDAR and ultimately increasing to cameras, those perception sensors generate massive amounts of data. And that data needs to be stored and used in the vehicle, but the OEMs don't typically have processes or the infrastructure in place to get it off the vehicle, just because it's so much data. It's such a large pipeline.
And what is different about Tesla? Is Tesla different in that regard from the other OEMs?
Yeah. Oh, yeah. Massively different. So Tesla, we've had a long relationship, not an official relationship as a company, but as individuals. We've known a lot of folks at Tesla, again, from early employees back in 2004. One of the co-founders was an early advisor for us. We know Mark and Martin for a very long time. Their approach to this space was so different. They really weren't car people. They were technologists. They were first and foremost computer guys from Silicon Valley. And so what they really built wasn't a car. They built a data center. They built a server that happened to have four wheels and a steering wheel. And so their approach was totally different. It's not clear to me that they necessarily took that approach because they were smarter or understood it any better or had anticipated it. I think they just took that approach because they didn't know any better. They didn't understand how the traditional automotive market worked and the way that things were supposed to be done. And so they just built a computer, and they built a centralized computer rather than a bunch of little distributed components like, ECUs as the automotive industry calls them, because that's what they did. They built a centralized computer. You wouldn't build a laptop with a bunch of individual components, one for the keyboard, one for the screen, one for the sound, one for the mouse, one for the trackpad. You built a centralized microprocessor that takes all that as inputs. So that's what they did. And the same thing applied to their approach to data is when Tesla built out their infrastructure, they approached it as like a data center, which means you collect all that information. You build the processes in place to not only store the data, but you have to get that data back to the mothership, get it back into the hands of your developers. And that just enables your developers to do things that are not well understood in the car industry, but are deeply understood in the internet world and the computing world. Things like A/B testing, that you push out one change to a small section of your customer base and a different change to a different section, and then keep a final section on the original rev. And you can watch differences in behaviors and make decisions based on that A/B testing. For the OEMs, for the traditional car manufacturers, that concept doesn't even exist. So yeah, they have a very different approach. They collect a ton of data, and they use that data in all sorts of fascinating ways.
So even Tesla, though, doesn't, when it collects data back from its cars, I assume it's not doing that in real time over a cellular network. Is it mostly doing that when you get home and connecting to a Wi-Fi, or how is the data actually being transferred?
Yeah, that's a really good insight. So they also have the same, pipeline problem that anybody else would have. They don't have some, magical pipeline available to them that nobody else does. So what they're doing is when the car is out on the road, they'll do something very similar to what the traditional automakers do, which is they'll use a much smaller pipeline, an LTE network, to send a very small amount of metrics data up to the cloud. So you can, at any given time, you'll have information available to you, simple information. But then, once it gets back to their customer's garage, where they are connected into the Wi-Fi network, and their customers are more than happy to give them access to that Wi-Fi network, those vehicles are not only streaming information off of the cars over that higher bandwidth network up into the Tesla cloud, it's actually also continuing to keep the vehicle on and use the compute that's inside the vehicle to run offline compute-intensive applications on the data that's stored on the vehicle to find even more nuggets of information and push that data up to the cloud. So they're actually using their Tesla fleet as actually an edge compute fleet as well as their customers' mobility fleet.
I see. So it's a little node in the network for them.
Yep.
So when you go a step further than ADAS, which is where Tesla's at, and when you go further to a fully autonomous vehicle, we all hear about how autonomous vehicles have these big computers in their trunk, and they're generating just tons and tons of data with all these sensors, as you point out, the cameras, the LiDARs, and everything. How does your platform that you've come up with work with autonomous vehicles to manage this data?
Sure. So ultimately, what our platform does is it provides a way for applications that are running in these vehicles to basically a framework for them to store that data locally, and then a framework that allows them to decide what data with what priority over what type of connections needs to be offloaded off the vehicle, as well as does it go to an on-premises edge device? Does it go directly into the cloud? Basically, what are those endpoints? Is it going to a backup drive, a removable drive in the vehicle itself for development fleets? So our platform is an end-to-end data management platform For the autonomous vehicles, where an 8-hour drive in an autonomous vehicle can generate 32 terabytes of data locally on the car, there's really no pipeline out there that's going to get all of that data off the vehicle, nor would you want all of that data off the vehicle. You'd be paying your favorite cloud service provider massive dollars in storage fees. So our system basically allows you to manage that data in the vehicle, manage applications that find those nuggets of gold out of that data, and then allow you to take that information off the vehicle. And it's really important for autonomous vehicles because of how much data they're generating. It's really important for ADAS test development fleets. They're maybe not generating 32 terabytes of data per day, but they're generating maybe 4 terabytes of data per day, 4 terabytes. So it still is a lot of data. And it's also important for production fleets, where you want to get as much data and as much intelligent data as you can off the vehicle and manage that whole process flow.
And so is the Renovo platform then taking other types of cars and making them more like a Tesla when it comes to the way that data is managed?
Yeah, you've got it in a nutshell. That's a really easy way to think about it is, our management platform allows you to do things like how Tesla is doing them. It allows you to create a rich management layer on your data itself. It allows you to run applications, workloads on that data in the vehicle, treat the vehicle as an edge processing device. It allows you to transfer the data intelligently, add filters, prioritization, retention policies, all of these things that are required in order to manage these massive amounts of data, which is exactly as you said. This is how Tesla treats their vehicles, and it's one of the reasons why, I think, in our opinion, one of the biggest reasons why Tesla continues to outpace the industry in terms of their ADAS feature set, in terms of their technology, in terms of the pace at which they continue to develop. It's something that we think is a critical piece of their success, and we're offering that to other manufacturers and tier ones.
So who are your customers in terms of type? Are they OEMs that are building cars, and then because historically they have not built a car with a central computer, as you point out, you're sort of adding that computer layer for them? Or is it an autonomous vehicle technology company that's then retrofitting a vehicle? How does your product connect with, integrate, and how do you sell to different customers?
Sure. So there's a wide range of the way that we integrate with different customers. You can take a company like Voyage, where in addition to this data management, we're also providing a lot of the infrastructure around how these applications actually talk to each other in the critical path for motion control and things like that. For them, we are effectively helping a part of their hardware stack. We actually are providing a lot of the hardware and the compute that goes into the vehicle, and we're actually retrofitting and putting a lot of that core functionality into the vehicle itself. For other customers, they already have existing ADAS boxes, large compute systems with relatively large local storage. In those cases, we look just like a pure software play. In that case, we're integrating into their existing compute environments, whether they're running Unix or some version of Linux, and we are putting our software systems on there. We're integrating into whatever their connectivity solution is. We're integrating into their storage solutions, and we're configuring the system such that it can run out of what the compute is that they have available. Obviously, the features and the capabilities that you can put into any one of these vehicles are highly dependent on the hardware that's located. If we are coming in and specifying that hardware, we can provide a much more feature-rich platform. But we've been very successful at integrating into something as simple as a Raspberry Pi with relatively small amounts of telemetry data, all the way up to the types of compute that we put into our own fleet of Pacificas, our development fleet for Pacificas, which have up to 3 kilowatts of server compute in them.
And So is your platform like an operating system, or how do you think about where it sits in the software stack and interacts with the different pieces?
Yeah, yes, good. I laugh just because the OS is such a charged term in the industry, but
More than platform?
Yeah, no, exactly. Well, platform isn't so much a charged term. OS seems to be one of these terms that people get angry if you don't describe it correctly or adhere to some definition that doesn't exist. Platform is just an overused term. I wouldn't say it's a charged term. It's just an overused term. But yeah, so although we work with, if you kind of think about the software stack, we work with kernel providers. So we have a great relationship, for instance, with Qnix. We were in their booth at CES earlier this year. We work with them to use the features that they provide in those kernels and tightly integrate with them and work on new features and development. But we're not involved in the kernel space. We don't get involved at that layer. I would say we sit kind of above that layer, but below the application layer. Although we also at times are required to go in and write some application level work, we're basically the infrastructure or the glue that ties together applications for their data management and their messaging, as well as we also have the capability to manage those applications. So you can kind of think of us sitting below the application layer and in some cases also above the application layer, where we can manage, particularly with workloads, whether those workloads are being launched, whether they're being halted, constraining them in terms of their CPU and their memory footprints. So we really are trying to provide frameworks that sit on top of the kernel but below the application layer to manage all this fun data that's running around.
And so your system works with any autonomous drive system or any type of ADAS that different companies might come up with, including the different sensor suites that might be involved in those products?
That's right. That's exactly right. I mean, at the end of the day, we are agnostic to the data itself, like what the data actually is, and whether that's a camera frame or whether it's a numeric value for steering angle. We don't care what the data is. We have the ability to handle large, what's blob data, like camera frames, very large object data, structured or unstructured, as well as down to individual numeric values. We can handle all of that, and we have processes in place to tell the system what to do with that data in terms of, should this data be taken off the vehicle? Should it only be taken off the vehicle when certain events happen? Should it only be taken off the vehicle when you have this sort of a connectivity in place? So we have processes and management features in place that allow you to tell us what to do with the data, but it doesn't really matter what the data itself is. And so in many ways, it doesn't matter whether it's an AV or an ADAS vehicle or just a standard production vehicle from our platform perspective.
So let's talk a little bit about the future of autonomy. You are a car guy and a tech guy, and you've been around in the space for a while. I guess we've seen the Gartner hype cycle playing out maybe a little bit in slow-mo with autonomous vehicles. We've been in this trough of disillusionment. Are we back now? And nothing like a pandemic to make you want to eliminate humans from your car. Where do you think we are in the autonomous vehicle space? What do you think is going to happen next?
Yeah, I'm still very bullish on the autonomous vehicle space. As you said, I think 2019 was a bit of a tough year for a lot of the autonomous startups. We saw the exit of a number of them, as well as kind of very beginning of this year. I think the folks that are still in the game, that are still out there, their technology is really, it's come a long way. It's making great progress. And as you said, this recent pandemic has really highlighted the fact that you can imagine a world where you don't have to interact with a stranger when you're trying to go from point A to point B. We think that's probably not the main motivation for And a fully autonomous vehicle, I think, I still feel the main motivation, and I still am a firm believer in this, is that autonomous vehicles, when they hit, will change our society radically. In my very humble opinion, it will be a bigger deal than computing or the internet. I was an original designer on the Pentium way back in the early 90s on the original Pentium. So I saw what compute has done for the world. I think changing the way that we move and changing the way we interact with that movement is going to be just radically transformative in our society. When it happens, I'm still quite bullish. I think the companies are making great strides. Obviously, the pandemic in some ways is helpful. In other ways, of course, it's tough, just like every other business on the planet. We're all struggling to make sure that we can exit the other side with cash and customers. But assuming that those companies that are able to do that, I think they've got a bright future ahead of them.
And what do you think about the development of ADAS? I've always been one of these people who thinks there's level 2 and there's level 4 and there's nothing in between. I can't even use cruise control on my car without falling asleep on the freeway. So I'm not going to be an autopilot user. Will there ever be a level 3 car? Do you see this as a gradual development, or are we just going straight to level 4?
That's a very fun topic as well. So I'm a big, for myself, and this is my personal opinion, I'm a big believer in level 2. I think level 2, the standard ADAS feature set is also going to make us safer. I saw a really great talk by the Mobileye CEO last year, and I think he put it very well, which is if our primary interest is in safety and saving lives, ADAS is the right ROI. It's going to change. It's relatively low investment cost, and it will full stop save, but it will significantly cut down on the number of both fatalities as well as just general accidents. Level 4, as I mentioned before, at least for myself, I believe that it's the reason we chase that is because it's going to change the way our society works. Level 3, it's hard to see with driver engagements how you get a level 3 system to work. A number of the German OEMs are still very committed to level 3, and I think their approach is an interesting one. In many ways, I think it's smart in that they're saying that they're only going to allow the level 3 in circumstances where driver response time is not critical. It's not clear to me exactly what those situations are, but I think if you constrain the mission such that it only allows it to happen when driver engagement doesn't matter, that is possible. It's not clear to me what those situations are. And I think in general, though, just the idea that in any given situation that you could have the car driving itself autonomously and then nudge you in your rib cage and say, hey, I need you to take over. That's going to be really challenging. I don't see how that works given the human factor.
Driver engagement is not required until it's really required right away.
Exactly. So, yeah, that's exactly right. I think it's the right approach. I just don't know what those scenarios are. It's not clear to me what those are.
Yeah. And do you think that we need some sort of a technological breakthrough, whether it's a new or better sensor, better AI, or something to get to fully level 4 vehicles that can be commercially deployed in a reasonable operational design domain? Or do you think we just keep plugging away and chipping away at it and practicing and gradually expanding the places where these cars can drive and we get there?
I definitely believe the latter. I think at this point, the technical barriers are far and few between on level 4 vehicles. Obviously, as you mentioned, the ODD is really critical for that. It's funny, we just were talking about the ODD for level 3. So similar problem on level 4 vehicles, you obviously have to very much define exactly what is the scenario, what are the situations and the scenarios. But I think the sensors today, obviously, they can be improved. Probably the biggest improvement you can make on the sensors is cost. It's not so much capability, it's the cost. But in terms of the actual technical capability, we have the compute. The software algorithms are very mature today. I liked, you had Drew from Voyage, I think in last season's podcast, and he was talking about the fact that everyone was focused on the perception problem, but it's matured quite a bit, and now it's the prediction problem, and that was kind of maybe hiding behind the perception problem. Yeah. I think he's right, but again, in all of these places, I actually feel very confident that it's maturing. I mean, Waymo has been doing this for a really long time, and their disengagements look pretty phenomenal. In my mind, it's a matter of execution. It's just getting the work done, just continuing to kind of plug along. It's working through the logistics problem. That's really what's required. Yeah.
Well, let's hope so. I think we all have our fingers crossed and are rooting for the teams that are working on this to get there. So, final question. I understand your wife has turned you into a bit of a Twitter celebrity. I have seen the photos of you working from home. If folks haven't seen that, please check it out on Twitter. The costumes that you've been wearing for your work from home Zoom calls are fantastic. Your costume game is very strong. So I have to ask, did you own all these costumes before the pandemic? And if so, how did that happen?
So yeah, it's a funny thing. Yeah, my wife, I think when we first started the shelter in place, the very first day we had a team meeting, an all hands meeting at the end of the day to talk about just how things were going and, get a pulse from everyone. And at the time, I threw on one of my costumes. I thought it'd be a fun thing. And my wife snapped a shot of it and threw it up on her Twitter feed. And it kind of blew up. It certainly took off more than either of us were expecting. It's interesting too. I actually do not have a Twitter account, despite being a technologist and loving working on this and building things. I'm a bit of a social Luddite in terms of I don't have a lot of social presence, but my wife does. And so it's kind of funny how it's taken off. So in my entire life, I have always been a bit of an eclectic dresser. And I have a bit of a skewed sense of humor. And so, I have, these are mostly, not entirely, but mostly they're all things that were in my arsenal pre-pandemic. A lot of them I've made for our children. We have 3 kids. I've made their Halloween costume every year since they were born. So some of these are actually costumes that I've made for the kids. They're getting old enough, or at least our 2 oldest are getting old enough now that I can just barely squeeze into them, just barely. Or they're large and ridiculous enough that they were super oversized for them and they're only slightly oversized for me. So, I started probably, I don't even know, 80% of them are actually all costumes that I've made. Like these are all, things that I've made starting since I think one of the earliest ones that I've worn, I made in the mid 90s, 94, 95. I think it's one of the. So
that's great. Well, that's an impressive level of Halloween commitment. I know when I was growing up, we made our costumes because that was kind of all there was. But they were nowhere near as good as the ones that you've made for your kids. I ordered mine for my daughter on Amazon and was lucky to do that. But it's an impressive level of costume game. So thanks for keeping us all entertained.
Oh, yeah. No problem. I mean, I was just saying I like to build things. I like to create things. And I mean, whether it's costumes or fully autonomous vehicles, it's all the same thing really. And I have 2 sewing machines in the house, both, one from the 1950s from one of my grandmothers and the other one from the 80s from one of my other grandmothers. And we have lots of crafting and building sort of things.
I love it.
Here at the house. Yeah.
That's great. And lots of time in the pandemic for more building and hobbies. So.
That's right.
Well, thanks so much for coming on the podcast. Really enjoyed our conversation.
Oh, I enjoyed it as well, Michelle. Thanks for having me. And it's been great. It's been really fun talking with you.
All right. Take care. Thanks again to Jason for joining us. We'll leave a link to his wife's Twitter account so you can see the great costume photos in our show notes. Our show notes this season will be on our new publication, smartercars.substack.com. If you're enjoying the show, please leave us a rating and review on Apple Podcasts or wherever you listen to your podcasts. Thanks again for listening. We'll see you next time.